Thank you. So this, you see, these last three questions are very important. Who can tell me one of the reasons they are very important? Huge mark. Lot of marks. Look at all the questions we've been dealing with. 5 marks, 5 marks, 5 marks, then 8, 7, and suddenly 16, 18, 21. So these three, you must try your best to do something. Think very well in these three. So quickly, this one. Express in the form of that. What form do we call this? What do we call this? Something form of complex number. What is that? The Euler form of complex number. Or Euler, whatever it is. I was trained to call it Euler. So it might be your pronunciation that is correct. It doesn't matter. Now, quickly, the first thing we do is to find the value of R, which represents the modulus of the complex number, and theta, which represents the argument of the complex number. Okay? So, quickly, the modulus of our complex number, we're going to have to solve this together. It's not unlike the one I will just show you the solution. It's a kind of technical question. So I want to call the number, should I call it Z? No, Z is already used here, W is already used here. Remember, if I call it Z, it will be interfering with this step. So I don't want to call it Z. And I don't want to use U, V, W either. Give me a symbol I can use. Usually we don't use P for complex numbers. It looks weird. A or K? No, A is fine. No, that's a vector. Okay, so let's our complex number be A minus 3 plus root 3I. Okay, so focus please. So absolute R is the absolute value of A, which is the square root of x squared and y squared, right? Okay, so no, actually I call it S. Absolute value of x. Remember, if x is a plus bi, then the absolute value of x is square root of a squared plus b squared. Okay? So here it's going to be minus 3 squared plus root 3 squared. So that will be square root of 9 plus 3, which is root 12, which is allowed, or 2 root 3. Okay? Now, argument. To do argument, I told you something. I said, draw the Argand diagram. That gives you an idea what it should look like. Draw the Argand diagram. This is the x coordinate, this is the y coordinate. Sort of. So we call it real coordinate and imaginary one. So the x coordinate is minus 3, the y coordinate is positive. So your complex number looks like this on the Argand diagram. Understand? And your argument is this measure from here to here. And when we did it, probably forgot, we always form a right angle triangle. Clearly, our argument is more than 90. 90 is pi over 2. So what I told you is, rather than finding your theta directly, find a smaller angle, call it alpha. Then your theta will be 180 minus alpha. Am I making sense? Stop using arctan, square root calculator. Calculator gives you something. You don't know if you have to subtract anything. See it here. The picture is clear. So, because I'm dealing with a right angle triangle, now remember this is minus 3 and this is 3 itself. No, root 3. Right? So if I'm dealing with the right angle triangle to find that alpha, I will be dealing with positive root 3 and positive 3 here. My interpretation knows that it is negative. The purpose of this negative is to tell me, oh, it's on the second quadrant. Not when I'm doing my calculation here. So I will not put negative 3 here. So I use tan. Tan of alpha is root 3 over 3. Alpha is equal to the arctan of root 3 over 3. And that is what? 30 degrees. Sorry, we have to use a radian. Pi over 6. Okay? Is it pi over 6? Yeah. Root 3 is 60. 1 over root 3 is 30. So that's pi over 6. Ask me a question. I need everybody to focus. Ask me a question if you have any. Any question? Come on, speak.
How is that related to sine and cosine? Like, how do you memorize that?
Oh, that one. We can talk about it after I'm done with this. Okay. But it's something they forced you to do in Nigeria. Not like force. I enjoy doing it actually. Again, I showed you last time. Sine 30, 60, and whatever. Let's try to remember the triangle. I need everybody to talk. If I want to discuss 30 and 60, what kind of triangle do I construct? Equilateral, thank you. Of side, odd unit or even unit? Even unit. So make use of 2. So if you forget, remember this. So when you do this, you have your 60 here, you have your 30 here. 60, 30. This is 2, this is 1. Use Pythagoras Theorem. 2 square minus 1 square, square root of 3. So if I need, here, look at sine 30, 1 over 2. Right? But I need root 3 over 3. Root 3 over 3 is the same as 1 over root 3 by rationalization. If you multiply by root 3 over root 3. So this will be 3 root 3, so 1 over root 3. And that you can see from here. 1 over root 3 is what? The tangent of 30 degrees. So if you write this out and you write sine, cos, tan of each of the angle, you can always pick which one belongs to what. Understand? Okay, I'll go back quickly. So from here, theta is definitely 180 minus alpha, 180. You see, this is a beginner's approach especially. Some people can use circular function and quickly get this value. Understand? So what is this? 5 pi over 6. So this is the argument. Some of you were writing minus pi over 6 or whatever. How is that possible? The complex number is not here. If it was here, then yes, it is negative. But it's here. And again, do not forget, your arguments must lie between here and here. Okay? So it's your arguments lying here. Whenever we, talk about our argument, we usually discuss the principal arguments anyways. Anyway, so we have pi over 6. Is pi over 6 in between that range? Yes, it's not up to pi yet, because 6 pi, you understand what I mean? So that's, you choose that. So again, your diagram is clear. Your diagram is clear. Now, let that be the roots. So for the roots, we use De Moivre's theorem. Remember? If, by De Moivre's theorem, if z is equal to r exponential I theta, or r CIS theta, De Moivre's theorem says z to the power n is equal to r n CIS n theta. Remember that? So this was what we expanded to what? To the root of complex number. And some of you got the formula right. The only issue was you were using the wrong argument. I think I have a few people that did that. Only using the wrong argument. So again, if you have z cubed is equal to this complex number that we have been dealing with, so automatically z is equal to the cube root of that. So we can say the complex number raised to power 1 over 3, something like this. So you recall your square root of complex number from, is this complex number x? Yes. From x, from square root of n root of that is equal to r raised to power 1 over n, remember this? Then CRS, the argument plus what? 2k pi all over what? Over n. Where your k is from?
0.
Well, in this case, our argument is not from 0 to 2 pi or anything. Our argument consider a part of the negative. That's the only difference between, I think this is the first time we are solving a question that requires a negative value of k. If you use 0 to pi, you realize 2 goes beyond the range of what the arguments will be. And since we are doing this because of the periodic nature of sine and cosine, it only says k must be an integer in the normal trig approach that we always use. So we go to k negative 1 instead. So instead of 0, 1, 2, your k will be from minus 1, 0, and 1. This is the only condition that can guarantee the argument to be within this range. That was the major issue for some of us. So if we substitute, so let's say for example, let's substitute first before we think about the k. We have our z, which is the cube root of this, will now be the modulus of this. Hello, are you with me? The cube root of this complex number is given by the modulus of this complex number to power 1 over 3. So this time around we have our root 12. I'll keep it at root 12 raised to power 1 over 3, which I will later write as raised to power 1 over 6. Does everybody understand why? Then you have CIS, our theta, 5 pi over 6 plus 2k pi, watch this, divided by 3. Is that not? So if you combine this, this will be 5 pi over 18, CIS, 5 pi over 18 plus 2 over 3k pi. Yes? Now check. When k is equal to 0, this is gone. 5 pi over 18 within the range. Hello? When k is equal to 1, you have just addition of 2 pi. Is that not? When you had 2 pi, okay, let's just do it. Look, oh my God. 12 CIS. I'm writing CIS. You can be evaluated by yourself later. Okay, so for k equals minus 1, 0, since minus pi must be less than theta, must be less than that. This theta is the argument. So this argument applies to the argument of this. This is a new number. Whatever we get, they are new complex numbers. Understand? So the argument must also be within the range of the original number. So when k is equal to negative 1, we subtract that. So we get 5 pi over 18 plus negative, right? Negative 2 over 3 pi. Now 2 over 3 is the same as what over 18? 12 over 18, right? Okay, so what would that be? 12, 1 over 6, CIS, minus 7? So is minus 7 over 18 pi within the range? Yes, but what would be the number? I'll probably will leave it at that. Minus 7. That doesn't look like what I'm supposed to have.
I think that was the answer.
That's correct? That's correct? Oh. Okay, I'll check the math scheme in a bit. So 7, 12, 1 over 6, CIS, for 0 is simply what? 5 pi over 18. Please take your time to work this out. Then for 1 over 6, CIS, when you had 2 over 3, what do you get? 17. Hello, talk to me please. But let's check 2. When you have 2, you get 4, right? So 5 pi over 18 plus 4 pi over 18 over 3. So when you multiply by 6, you get 5 pi plus 24 pi divided by 18. This is greater than pi. That's the reason some of you were having that issue. But you know you have to have 3 roots. So you have to look the other way, especially with that condition. Understand? So let's see. Let me see if I've not made any mistake there. So we have our root 12. Oh yes, minus 7. Okay, I thought that was something. So these are the U, V, and R. Oh, it's 1025. Just quickly show you the last thing. This question talks about triangle. This question talks about triangle. Just, show them on the Venn diagram. If you look at it, if you evaluate this, especially because of the argument can help you out here easily. Remember, you have a circular function, something like this. This, what is that? The first one, negative 7 pi. It means it's below this axis. Now, 7 pi is close to half of pi, it's close to minus pi over 2. Do you agree? Because 9 minus 9 over 18 will be this. Am I making sense? So the first one is going to be somewhere here, it's close to here. Am I making sense? So if I call this Z1, 2, and 3, so this is my Z1. For the second one, 5 pi over 2 is just going to be on the positive. It's also a bit far away. Now you see this is close to 90, but this is not so close. So this might be somewhere this way. Not so close, not like a reflection here. Am I making sense? So something like this. Then the last one, 17. So this is very close to what? Very close to pi. So we can have something like this. So if this is a triangle, what is the area of the triangle? That's the question. Okay? Do you understand? So well, let's see. Now remember, we mentioned that this angle is on the positive side now. 7 over 18 pi, yes? This angle we know to be what? 5 pi over 18. So the combination of these two angles is 12 pi over, yes? Over what? 18. So 12 pi over 18 is what? 2 pi over 3. That's 120 degrees, right? Talk to me, yes? 2 times 180 divided by 3. That's 120 degrees. This is 120. If you check the same, you're going to have the same 120 here. You're going to have the same 120 here. Okay, just check the angle of, this angle. So this angle from the beginning, okay, let's quickly check the other one. Let's quickly check the other one. Sorry, please. From here to here is what? Quickly. 17. This is my Z3. This is my Z2. That's 17, right? 17, but this is we already cut out 5. Can you see? So what the remaining will be? 17 pi over 18 minus 5 pi over 18, giving you back 12 pi over 18. If you do the same for this one, we have this to be 7. We need the whole of this, right? Oh, I have this to be 17. I have this to be 7. So I can find this, right? As 360. Hello? Minus 17 pi over 18 minus 7 over 18 pi. This is going to be 36. 36 minus 24. What do we get? 12 again. Hello? So there are congruent isosceles triangles. The isosceles triangle is like this, with in between 2 over 3 pi. And what is this? What does this line represent? The modulus. Isn't that the length? Alright? The modulus. And the modulus is your 12 raised to power 1 over 6. The same thing, 12 raised to power 1 over 6. So the area of the triangle that is represented here is just the area of one of them times 3. So basically it's 3 times half a squared sine theta. I use a squared because a and a are the same in this case. So basically it's going to be 3 over 2, 12 raised to the power 1 over 6 squared, sine of 12 pi over 18, something like that. And that is how you find the area. Apologies for taking so much of your time. So you see? But you must be able to. So the best way to do this is to draw that shape. It's difficult sometimes to imagine. I know, it looks complicated. Like, oh my God. Yeah, I know. If you need me to explain this next time, I will. And if you guys want to come to Zoom, I don't mind. Just kidding. It's like, no, I don't want to come to Zoom. Okay, we'll call it a day here. We'll continue next time. We're not going to do a repeat of paper 1, 2, 3 on the same day anyway. So we could do, Monday is a double period, so I propose we do 1 on Monday. Because it's a double period. So it could be paper 1 on Monday. It's going to be exactly like our paper 1. But instead of having how many hours is paper 1? 2 hours, you have just 90 minutes. And maybe 10 minutes with your recess if you want. But I want it to give you the best. It's going to be looking exactly like that, but not the same question. Let's see what you remember from the correction of paper 1. Unfortunately, this is still paper 1, right?
Yeah. Yeah.
Do you mind if I send you the mark scheme then? Okay. Hopefully you can understand what was done. Okay? I'll send you the mark scheme. Just study paper 1. We'll repeat paper 1 on Monday. Thank you. Separate them, please.